mga ka-super science! Welcome to another amazing week of learning. In this video, we will learn sound propagation, effect of temperature to the speed of sound, and properties of sound. Ready na ba kayong matuto about sound? So, tara! Every day, our world is filled with sounds. It's either a beautiful sound or in the form of noise. Sounds are caused by vibrations. We can create sounds through various ways,
such as clapping our hands and strumming the guitar.
Sound is a longitudinal wave that needs a medium in order to propagate. These are waves that travel parallel to the motion of the particles. Sounds are also known as mechanical waves since sound waves need a medium in order to produce.
This media can either be solids, liquids, or gases. Take note that sound cannot travel in a vacuum.
Sir Isaac Newton found out that the speed of sound can be affected by elasticity and density of the medium.
Elasticity is the ability of a material to return to its original form after a certain amount of force has been applied on it. Steel is an example of an elastic material.
Sound travels faster with more elastic objects. This is because the atoms and molecules of elastic materials have a strong attraction towards each other and also responding faster to each other's movement.
As a result, sound energy is transferred more quickly. Then, we can generalize that solid or the more elastic, followed by liquids and then by gases. Thus, sound travels fastest in solids and slowest in gases. Imagine talking to someone who is 100 meters away. You would have to shout if you use the air as the medium to sound. However, if you allow the sound to travel through a solid, such as the string of improvised phones made from tin cans, you will be able to send a message across just by whispering.
The next factor that affects the speed of sound is density. It is the mass of material per unit volume. The denser the object, the slower the sound waves propagate. This factor applies when comparing mediums of the same phase.
For example, sound travels faster in helium than it does in air, as helium is less dense than the gases that make up the air. You can observe that helium is less dense than air because balloons filled with helium float, whereas those filled with air do not.
So move on na tayo sa temperature of the medium as another factor affecting the speed of sound. Temperature is the degree of hotness and coldness of a material.
Heat, just like sound, is a form of kinetic energy. At higher temperature, particles have energy and thus vibrate faster. Since the molecules vibrate faster, sound waves can travel more quickly.
Take note that in dry air, which is at 0 degrees Celsius, the speed of sound is 331 meters per second.
It means that when temperature is greater than 0 degrees Celsius, the speed of sound is greater than 331 meters per second. The speed of sound increases by 0.6 meters per second with every increase of 1 degree Celsius. Thus, the speed of sound in air may be computed using the formula V equals 331 meter per second plus 0.6 meter per second per Celsius multiplied by T, where V is the speed of sound, T is the temperature of air, and 0.6 meter per second per Celsius is a constant factor of temperature. So let us solve a sample problem. Number 1. What is the speed of sound in air if the temperature is 30 degrees Celsius? So, i-identify muna natin ano yung given sa problem. So, we have 30 degrees Celsius, which is the temperature. Then, we are looking for the speed of sound in air. Then, ang equation natin ay V equals 331 meter per second plus open and close parenthesis 0.6 meter per second per degree Celsius. Multiply by the temperature. Next, for the solution, we need to substitute the given, which is the temperature of 30 degrees Celsius. So we have V equals 331 meter per second plus open and close parenthesis 0.6 meter per second per degree Celsius multiplied by 30 degrees Celsius. So let us bring down 331 meter per second, then multiply yung 0.6 meter per second sa 30 degrees Celsius. So take note na kailangan natin i-cancel yung same unit. So we have 0.6 meter per second times 30 is equal to 18 meter per second. So we have 331 meter per second plus 18 meter per second is equal to 349 meter per second. So, the speed of sound in air at 30 degrees Celsius is 349 meter per second.
So there are amazing contribution of sound to other fields such as health and arts, particularly sa music industry. And we can observe this as consequences of what are commonly called as properties of sound.
Ultrasound works on the principle of reflection of sound waves, while open-field concerts benefit from the refraction of sound.
Do you want to know more about these amazing sound treats? Let's go!
Isa ka ba sa mga taong mahilig kumanta habang naliligo?
This life is easy, yeah, when my world's falling apart, when there's no light to break up the dark, that's when I'm happy.
Maybe you are wondering why your voice is trembled in the bathroom while singing in other places.
Believe it or not, there is a scientific explanation behind your beautiful voice inside the bathroom.
The hard walls and small dimension of the bathroom create a pleasing acoustic environment. Yung bathroom tiles ay hindi nag-absorb ng sound. Your voice bounces back and forth around the room, creating many echoes and reverberation, contributing to the fullness of your voice.
Just like any other wave, sound also exhibits reflection. Reflection is described as turning back of wave as it hits a barrier. Echo is an example of a reflected sound. Reverberation, on the other hand, refers to the multiple reflection or echoes in a certain place.
A reverberation often occurs in a small room. This best fits the bathroom, which enhances the voice.
The next property of sound is refraction. Have you ever wondered why open-field concerts are usually held during nighttime? Usually, sound is heard better in far areas during nighttime than daytime. This happens as a result of refraction. Refraction is described as a change in the direction of waves as they pass from one medium to another. So earlier, we have learned that sounds travel faster in a hotter medium. When sound propagates in air, where the temperature changes with altitude, refraction happens. At daytime, the air molecules near the ground are hotter than the air molecules at higher altitude, so sound waves refract upward. On the other hand, during nighttime, the air molecules near the ground is cooler, so the sound waves refracted towards the ground. This makes open-field concerts better held during nighttime, as sound waves are refracted from the stage towards the audience. This gives a clearer and more audible music to enjoy. At dito na nagtatapos ang aking video lesson about sound. So I hope na marami kayong natutunan. Thank you for watching and don't forget to like and subscribe to our channel, the Bataan Science Channel. Goodbye!